Hi, welcome to Solve the Papers channel. I'm Godfrey. In this video, I'm solving Cambridge A2 chemist. Our topic is entropy and Gibbs free energy. This is a October-November 2019 exam series. Always I encourage my students to do their revision topic-wise. Read a given topic, and when the content of that topic is fresh in your mind, attempt questions that are set on various years, 2019 going backwards. You'll find all those topical questions in this site here, solvedpapers.co.uk. In this way, you'll get to know for every given topic the key areas that the examiners emphasize on, and this will give you an edge as you prepare for your exams. I'm sure you're looking forward to getting your ESTA. That is a sure way of getting your ESTA. Once you're done with the topical questions, then you can resort into looking at full past papers. Get a full past paper, time yourself, and see how long you're going to take to get done one paper. Of course, the past papers in A2 is in chemistry will be 2 hours. You need to know that you need to get that paper finished, complete in 2 hours. If you are not able to complete in 2 hours, practice on more past papers, and this will be a good thing to build your speed. You'll always be able to know from where these questions are obtained from when you look at this writing here. Of course, this is this question that you are starting with is from variant 4.1, and this was number 3 of October November 2019 exam series. Of course, 9701, that's the code for chemistry exam in L level for CIE. That's out of the way. I would like to urge you guys, if you are not already subscribed to my channel, please click the subscribe button and hit the bell icon. This way you will be notified every time I upload a new video. May we get started? Number 1A, explain what is meant by the term entropy of a system. Entropy of a system. Alright, then entropy of a system is the measure of the degree of disorder of that system. It's basically that. This is the measure. Entropy of a system is the measure of the degree of disorder. How much disordered is the system? Degree of disorder of a system. A system can be anything. A system can be your room. If your room is so messy, clothes everywhere, that room is disordered, and of course you can talk of that as an entropy of your room. A system can be a chemical reaction. A system can be the surrounding, and so on and so forth. Part B, state and explain. Always watch out for those two keywords, state and explain whether the entropy change of each of the following processes is positive or negative. Do not consider entropy changes of surrounding. We only consider the entropy change of the system here. So liquid water at 80 degrees Celsius is cooled to 60 degrees Celsius. So the entropy change here will be negative. The entropy change is negative because the molecules are losing energy to the surrounding. The molecules, of course, of water, the molecules of less energy. They have lost energy to the surrounding, as less energy in the system. Of course, the energy has been lost to the surrounding, although we are told we shouldn't take into consideration the entropy change of the surrounding. Solid calcium chloride is added to water and the mixture is stirred. Here the entropy would be positive. Calcium chloride is soluble because calcium has dissolved in the water, and dissolving of a solid in water, or to make solution, increases the randomness, randomness of solid particles. So the solid now can move from one point to another, and this creates an increase in entropy change. And increase in entropy change is positive. There is an increase in entropy change, which is positive. The change corresponding to the lattice energy of calcium chloride takes place. Okay, the change corresponding to the lattice energy of calcium chloride takes place. So the entropy change here will be negative. The entropy change will be negative because the gaseous ions of the elements are converted to a solid. The gaseous ions of the element, of course, of the elements, calcium and chloride, are converted into a solid. Of course, a solid has got less entropy compared to gaseous state. Therefore, if you're moving from gaseous to solid, then the disorder decreases, and that means that the solid is more ordered. Therefore, the entropy change is negative right there. Part C, the reaction zinc carbonate to give us zinc oxide and carbon dioxide is not spontaneous at room temperature. Give the full name for the term, a change in G there. Of course, this is what we call the standard Gibbs free energy change. This is a standard Gibbs free energy change. Of course, if it was just G, this is a Gibbs free energy. But since it is having this here, that means it's standard, and of course this triangle here is change. So then standard Gibbs free energy change. Part 2 of C, describe how temperature at which the reaction becomes spontaneous can be calculated. Include an equation in your answer. The equation is always obviously going to be standard Gibbs free energy change is equals to enthalpy change minus temperature multiplied by the change in the system. All right. So here the reaction will be spontaneous when delta G is going to be 0. So you need to calculate the value of T at G is equals to 0, and of course you get the value for T, because you're supposed to describe how temperature at which the reaction becomes spontaneous can be calculated. So the reaction will be spontaneous, or will just convert zinc carbonate to zinc chloride and carbon dioxide. That is spontaneity. Spontaneous will be spontaneous when delta G will be 0. So we need to calculate we need to calculate value of T at delta G is equals to 0. Therefore, if G is equals to 0, then we'll have enthalpy change minus T delta S. Therefore, T delta S is equals to the enthalpy change right there, and T will be equal to enthalpy change of entropy change of the system. So we'll have gotten our T right there. Very well. You always insist that I always encourage you guys to practice working out these questions yourselves as I guide you. Remember, practice makes perfect. You practice working the questions, you will be building confidence in this area on entropy and Gibbs free energy topic. You may get this same paper I'm solving right now from this site here, solvedpapers.co.uk, and the site I'm talking about is this one right here. This is solved papers. If you go home, this site is solved papers for CIE. It's a very resourceful site. You need to come to A-level chemist. Of course, you can get papers for all this, both past papers and topical questions. We are in 2018, 2019 A2. You get there. You find that we have November and June topical questions there for A2. Yeah, all these questions are arranged topic-wise. We are dealing with the Gibbs free energy. Here, I need you to come download this. You may get all these other topical questions by clicking over here. When you click here, you will be taken to this site here. And of course, this is A2 November 2019. You can get to 2018, 2017, 2016. All the papers are available, or you can get all of them at a discount. Of course, you need to come to chemist. The papers are just slightly less than £10. You may ask your parents to help you in acquiring these papers. You only need to click here, add it to a cart, and then view the cart and check out. Of course, you can get for also on June, same. Get as many topical questions as you can and practice. And while we are at it, of course, also could be of help. If you ask for my help, I would be glad to help. I am online and teach some tuition classes online at this site we call spacademy.co.uk. The site I'm talking about is right here, spacademy.co.uk. If you visit this site, you can explore. We offer ICT, mathematics, physics, biology, and chemistry with other colleagues of mine. I'll need you to come here to student guide, get a step-by-step guide on how our site works. You may also need to watch this video to get familiar with the online live classes. Once you have made up your mind, you need assistance. You need to register, of course, and create your own account. You need to register and create your own account. We will send you an email, so you give us your correct email. In the email, you need to activate your account. Once your account is active, you can come and sign in and click here to find a tutor. And I will be glad to help. Contact me and we can work out this together. My charges are only £35 per student. If you are 4 or more students, I'll charge you £25 per hour. Looking forward to seeing you. Now, question number 2 was set on variant 4.2. This was question number 4. The table shows some standard entropy data. Of course, we have the substances here: lead oxide, solid, and of course lead oxide. This is lead, I think lead 4 oxide, lead 2 oxide. This is oxygen. Their standard entrophies are given here in joules per Kelvin per mole. Lead 4 oxide decomposes to lead 2 oxide and oxygen when heated. The equation is given here. You heat this lead 4 oxide, you'll get lead oxide and oxygen. Then the enthalpy change is given here, plus 118. This is an endothermic reaction. Use the data to calculate the value for standard entropy change for this reaction. Of course, we know that the entropy change, the standard entropy change, is usually given by entropy of the products minus the entropy, standard entropy of the reactants. Of course, you need to consider the the stoichiometry of the reaction here. So it will be 2 times the entropy of lead, standard entropy of lead, which is lead oxide, which is 69 plus, these are the product, oxygen is just 1 plus 205, and all of this you take away the entropy of the reactant, which is 2 times 77 right there. Of course, when you work out, you're going to get 43 minus 154, and this will give you plus 189, and that will be joules per Kelvin per mole. So plus 189. You have to give plus to show that the entropy has increased, and it has increased because you are getting more products than the reactant, so the disorder will be a little bit higher. Part B, use the value of the enthalpy change of your reaction and your answer to part A, which is this one, to calculate the temperature at which this reaction becomes feasible. The temperature. So you're going to use the Gibbs free energy reaction. So delta G is equals to delta H minus T delta S. Of course, this reaction will become visible when the value of G is 0. So you can take note of that. The value of G, the value of delta G must be negative for the reaction to be spontaneous. So we usually take the value of G we take the value of delta G to be 0, because after 0 then you go to negative. So then of course this becomes 0 is equals to delta H minus T delta S. When you make T delta S subject, you get delta H. Therefore, T is equals to delta H over delta S. And here we are given delta H. Delta H of this reaction is this. You must change this one into joules per mole. So this you multiply by 1,000, you get 118,000 joules per mole. Change that. So bring it over here. Bring that over here. So then, of course, this will be 118,000 and divide by the entropy change here, which is this one here, which is 189. Correct evaluation will give you 624.3386, and therefore T will be approximately 624 Kelvin for the reaction to become feasible, for the reaction to be spontaneous. Part C, solid lead 2 oxide can be made by heating lead metal in air. Predict the sign of the standard entropy change of this reaction. Explain your answer. You just heat in air, so when you heat lead plus oxygen, what you get is lead 2 oxygen, which is solid, of course, right there. So on the reactor side we have two elements. On the right hand side we have one product. So from elements to a product, the entropy change has decreased, so entropy change will be negative. So entropy change will be negative, will be negative. The reason is the number of the molecules has decreased from 2 in the reactants, from actually this is oxygen here, so yeah, so we need to multiply this by 2. This is by 2 right there. So we have 2 plus 3 molecules from 3 molecules in the reactant side to 2 molecules in the product side. So the decrease in the number of molecules from 2 to 3 will result into less disorderedness, and therefore the entropy will be negative right there. So that's it. We only had these two questions from entropy topic for October, November papers. Get more papers, as of course, as I always say, from solvedpapers.co.uk. You can get more topical questions. Attempt as much as you can. You need my help, you know where to get me, spacademy.co.uk. Hopefully I'll see you guys in my next video. Have a great time. Bye.